So example 2 is applying what we just did in example 1 by taking all those properties and actually putting them on the graph. So we're still going to go through the same processes as before. We may not show all the work, but we're going to go through the same processes to achieve the same goals so that we eventually can put some points on my grid here. So first thing I want to do is just identify intercepts. So y is always the easiest. It's that constant term at the end, -14. My x-intercepts I'm going to have to figure out by solving, or by factoring rather. So I'm going to take 0 equals -2, and I'm going to factor out that -2 right away. X squared minus 5x plus 7. And I'm going to break that farther apart, divided by -2. And there's actually no way of factoring that. So I'm going to end up in a little bit of a pickle here, but I'm going to get some other information as best I can. Okay, there is a way to deal with this, we just haven't learned it yet. So 2 is to figure out your x value of your coordinate or your axis of symmetry. Because we can't find our x-intercepts, we can't use the mean theorem, so we have to use x equals -b over 2a, which means it's going to be -10 divided by 2 times -2, which gives me positive 10 divided by 4, or 5/2. Finally, then I'm going to solve for y, and that's going to be by plugging in. And again, in this case scenario, I don't think it's a bad idea to use your calculator, but I'm going to write out at least my first step so I know exactly where to plug in all these values, and that so that I don't plug them in incorrectly. Plus 10 times 5/2 minus 14. Now this actually doesn't become too bad in terms of manageability. This becomes -25 over 2 plus 25 over 2. Sorry, it's 25 and then minus 14. These will simplify. And again, this is just using mental math strategies. Here I looked to take out that 2. 2 goes into 10 evenly, so I simplified that. This squared is going to be 4, but again, 4 goes into 2 to reduce. So that's where those numbers are coming from. And I'm going to say, okay, well, these are whole numbers. They can combine. That would give me 11. Okay, but I'm looking at over 2, so I've got 25 plus 11, or 22 over 2, which will leave me with -3/2. So those are my coordinates. Vertex is at 5/2 and -3/2. So now I've got that. I can tell you that my direction of opening is going to be downward. Okay, it's changed by a factor of 2, just like before, and I have my y-intercept. So when I go to graph this, I'm going to have to be very conscious of this. So I need to be able to go all the way down to -14. So I'm going to go down by 2 in order to make that goal. Even then, I'm not sure I'm going to make it. 4, 6, 8, 10, 12, 14. I'm just going to make it there. Okay. I also know my vertex is at positive 2.5. I'm going up by 1. No, let's go up by halves, just because I can. So 2.5. Don't forget to label your axes. And -1.5, so about here. From here, I actually don't have any x-intercepts. I can see that now My vertex is below my x-axis, and I'm opening downward. So that's what my parabola is going to look like. And so it kind of makes sense that I don't have any x-intercepts. So everything kind of all comes together. In that case, because we only have those 2 points, it's very much going to be a rough sketch of what your parabola would look like. So it's not going to be as perfect as we have on some of our previous examples. Just try and make it look symmetrical. So what I'd like to see you do is pause the video right now and try this part B on your own. Find all those different pieces, put them on the graph. So again, to walk you through this, if you are unsure, one is looking for intercepts. Well, y is going to be at +5 because it's that constant term. Okay, to solve for my x-intercepts, I'm going to try and factor this. Well, let's see if this is factorable. Could go 4x and x. Then I could go 5 and 1. Well, that wouldn't get me where I need to go. What about 5 and 1? No, that wouldn't work either. Okay, what about if I did 2x and 2x? Maybe this will work. I think it will. Yeah, there we go. Okay, so I've got my factored versions here. 10 and 2 is 12, so that gets me my middle term. Awesome, that means my x-intercepts are going to be -5/2 and -1/2. So for part 2, to figure out my my axis of symmetry, I'm going to find the mean. I'm going to use that strategy here. So I'm going to go -5/2 plus -1/2, all divided by 2. Well, that is the same as I'm just going to note that those are intercepts. 5 plus 1 is -6/2, divided by 2 is going to be -3/2. Okay, so that's my x value, my x-axis of symmetry. I'm going to solve for y, get my vertex. So I'm going to go y equals 4 times -3/2 squared plus 12 times -3/2 plus 5. Solve this guy. That's going to allow me to go, okay, well, that ends up being actually just +9 minus 6 times 3 is 18 plus 5. And so that gives me, again, my strategy being 2 divides into 12 evenly and gives me 6, so 6 times 3. Same thing here, 2 squared is 4. Well, it's going to cancel out with my coefficient out in front. So that's how I simplified those quickly. 9 minus 18 is -9, because 9 plus 9 is 18. So -9 plus 5 is going to give me -4 as my y value. So my vertex is going to be at -3/2 and -4. Okay, so now when I go to graph this, I've got loads of values to use. I've got y equals 5. So I need to go up to 5 vertically, and I need to go down to -4 according to my vertex. So luckily that fits within my counting of 1, so good news on that front for my y-axis. My scale on my x-axis, I can wiggle a little bit because I'm dealing with that fraction again. So I'm going to go down by halves again and up by halves. So then when I go to actually, and that also is helpful when I look at my intercepts here. Okay, so now when I actually go to plot, y equals 5 is going to be all the way up here. X-intercepts at -5/2 and -1/2 are going to be there and there. And then my vertex is going to be at -3/2, which we see now visibly. That's my axis of symmetry. Well, it's equal distance from both my intercepts. That makes sense. and it's going to be at -4. So sticking with my symmetry, I should also have a point here. And from there I've got some much better points to work with in terms of drawing my parabola. But you're going to want to be very careful to still be curving it in at that bottom part there. And that's how we would draw our parabola for this one. So a little bit nicer, a little bit more accurate than the previous one.